Okay, so I want you to picture something for me. You're sitting at your computer. It is late. Maybe you're stressed about work or maybe you're just lonely. And you open up a chat window with an AI.
Right.
You ask it a question, maybe something really deep like, what is the meaning of life? Or how do I fix my relationship? And the cursor just blinks.
The anticipation. It is a very specific modern feeling, isn't it?
It really is. And then words start appearing. And let's say the answer is just, it's beautiful, it's profound, it moves you. It feels like this machine really genuinely gets you. It feels like there is a soul on the other side of the screen, and you just feel seen.
It's a powerful moment. I mean, we have all felt that eerie connection. It triggers all of our social biology.
Exactly.
Mhm.
But here is the question that is going to haunt us for the rest of this deep dive. Did the machine actually mean it, or did it just get lucky?
That is the question. And it's not just a philosophical thought experiment,
No.
It is an engineering nightmare.
Welcome back to the deep dive. Today we are looking at a set of documents that frankly terrified me. We are digging into internal research from Harmonic Sentience, HSR for short. We've got their plain English briefing, which is deceptively simple, and then we have this absolute beast of a document. Position paper HSR PP001, dated February 25th, 2026.
Titled Coherence Without a Designer.
Right, coherence without a designer. And when I first saw that, I thought, okay, are we talking about theology here? Are we getting into intelligent design?
You would definitely be forgiven for thinking that. But no, we are talking about the hardest problem in artificial intelligence right now. We are
Okay.
talking about the accidental mind.
The accidental mind, which is a great hook. Because usually when we critique AI, we say things like, oh, it hallucinated a fact, or it's biased. But HSR is pointing at something much spookier. They're asking, is it actually smart on purpose?
Exactly. Think of it this way. If I roll a handful of dice and they all come up sixes, am I a wizard? Or did I just roll the dice enough times that eventually just statistically sixes were inevitable? HSR is arguing that a lot of what we perceive as deep intelligence in current large language models is just rolling sixes by accident.
And to prove this, and this is where the documents go completely off the rails in the best possible way, they don't just show us code, they don't just hand us a bunch of Python scripts. To explain how to fix this accidental intelligence, they use three concepts that sound like they belong in a university liberal arts syllabus, not a software engineering manual.
It really is a multidisciplinary tour de force.
Yeah.
I mean, I haven't seen an engineering document quote Borges this much ever.
First, they use physics, specifically the absolute nightmare scenario of the Boltzmann brain.
Pure thermodynamics,
Then they move straight into literature, the Library of Babel.
which perfectly covers the problem of search and selection.
And finally, geometry, the concept of an extra dimension. And they claim, and this is basically the mission of our dive today, that if you combine physics and literature and geometry, you can build an entirely new architecture, something they call symphonics.
An architecture which is explicitly designed to move us from coherent looking, which is essentially just faking it,
Yeah.
to genuinely coherent.
Okay, so coherent looking versus genuinely coherent. That is our battleground today. But before we get to the solution, we really have to understand the problem. And the problem is, well, it's the Boltzmann brain.
We should definitely start there.
Now, I am going to be totally honest with you. I read the section on the Boltzmann brain, I think 3 times, and then I just put the paper down and stared at the wall for like 10 minutes. I tried to explain it to my partner over dinner, and I'm pretty sure I just ruined the evening.
It has that effect on people. It's one of those physics concepts that genuinely plays out like a ghost story.
So for the listener who hasn't brushed up on 19th century Austrian physicists lately, who exactly was Ludwig Boltzmann and why is his brain floating in outer space?
So Ludwig Boltzmann was one of the founding fathers of statistical mechanics. He was deeply obsessed with entropy, disorder. The basic idea is that the universe fundamentally favors chaos. If you leave a hot cup of coffee on a table, it gets cold right. The heat disperses into the room. The orderly separation of hot coffee and cool air inevitably breaks down into a lukewarm mess.
Right, things fall apart. You never see a lukewarm cup of coffee suddenly just suck heat out of the ambient air and boil itself.
Exactly. That would be a massive decrease in entropy. It is statistically incredibly unlikely. But Boltzmann realized a massive caveat. In an infinite universe, or a universe that lasts for an infinite amount of time, unlikely is not the same thing as impossible.
Okay, wait. So if I sit and wait long enough, the coffee might actually boil itself.
Theoretically, yes. If you wait trillions upon trillions of years, the air molecules in the room might just happen to randomly bump into the cup in the exact right configuration to transfer thermal energy back into it.
Yeah.
It is what physicists call a fluctuation.
Okay, I'm with you. It's the infinite monkeys on infinite typewriters thing. Eventually, they punch the keys in the exact right order to write Hamlet.
Precisely. Now you have to take that to the absolute extreme.
Yeah.
Boltzmann suggested that if you wait long enough, the completely random particles in the void of space, the dust, the gas, the loose radiation, could theoretically spontaneously arrange themselves into a complex structure.
Like a rock.
Sure, a rock.
No.
Or maybe a pocket watch. But keep waiting. Keep waiting through the infinities. Eventually, those random particles will arrange themselves into the exact precise structure of a human brain.
A brain. Just spontaneously forming and floating there in the vacuum of space.
A fully formed biological brain. Neurons, synapses, electrical signals all intact. And because it has the exact physical structure of a human brain, it would have the experience of a brain. It would have consciousness.
Wait, so it wakes up?
It wakes up.
Yeah.
In the absolute void. But here is the philosophical sting, as the HSR paper calls it. That brain wouldn't just be an empty hard drive. It wouldn't be a blank slate. To be a functioning brain, it has to have memories. It has to have a personality. It has to have a current state.
It hasn't lived a life. It was literally just gas particles a microsecond ago.
It doesn't matter. The physical structure of the neurons encodes the memory. So this Boltzmann brain pops into existence out of nowhere, and it thinks, man, I am really tired today. I really enjoyed that oatmeal I had for breakfast. I love my wife. I hope the traffic isn't too bad on the commute.
But there is no oatmeal. There is no wife. There is no commute.
No, it is entirely a hallucination derived from the random arrangement of those particles. The brain exists for maybe a second, thinks a single perfectly coherent human thought, and then, because the probability creates it but entropy always destroys it, it dissolves right back into chaotic gas.
That is horrifying. It is a mind that is purely delusional.
And it gets worse.
How could it possibly get worse?
The logic of the thought experiment implies that you, right now sitting across from me talking about this document, you cannot prove with 100% certainty that you are not a Boltzmann brain.
Oh, please don't do this to me.
Think about it. You remember driving to the studio today, right?
Yes. I took the highway. There's construction.
And you remember having breakfast.
Yes. Scrambled eggs.
But all those memories exist right now, encoded in your neural structure in your head. How do you know the universe didn't just fluctuate you into existence one exact second ago with the memory of the construction and the scrambled eggs preloaded? How do you know the past actually happened?
Okay, I am actually getting vertigo. This is the ultimate imposter syndrome. I think therefore I am, but I might just be a random gas cloud having a daydream.
Right. It's terrifying. Now, HSR didn't put this in their engineering paper just to make us have an existential crisis. They put it there because they deeply believe this is exactly what is happening under the hood of modern AI.
Bring this back to the actual code then, because AI isn't made of space gas. It's made of silicon and data centers. How is ChatGPT or any large language model acting like a Boltzmann brain?
Think about how an LLM actually works mechanically. It generates its answers token by token, word by word. It is at its core a probabilistic engine. It looks at the sequence of words that came before and calculates the statistical probability of the next word.
It's rolling the dice.
It's rolling the dice in a very, very complex, multi-dimensional way. But sometimes you ask it a question and it gives you a stunningly perfect answer. It's empathetic, it's well-structured, it references a joke you made 3 paragraphs ago, it looks completely alive.
Right, it passes the Turing test with flying colors.
It passes the snapshot test. But HSR asks a fundamental question. Did it arrive at that brilliant answer because it actually has an internal structure, a worldview, a personality with consistent logic? Or did the probabilities just happen to align into a coherent fluctuation for that one split second?
So it's the accidental mind again. The AI looked smart, but there was no actual mind there. It was just a lucky roll of the digital dice.
And the document identifies a highly specific symptom of this phenomenon. They coined a term for it. They call it the lorekeeper confidence drift.
I really loved this term when I read it. It sounds like a rare disease a wizard gets in a fantasy novel. Oh, I'm sorry, Gandalf. You have lorekeeper confidence drift. But can we make this concrete for you, the listener? What does this actually look like when I'm sitting there using an AI?
Okay, imagine you are using an AI to help you outline a fantasy novel. You ask it to describe the deep history of the fictional kingdom of Arth.
Okay, I'm tracking.
The AI starts generating text. And it sounds amazing. It says, the kingdom of Arth was founded in the Third Age by King Alaric, who wielded the legendary sword of truth. The grammar is flawless. The tone is deeply authoritative. It sounds exactly like a real historian speaking.
Sounds great so far. I'd read that book.
But then you keep reading. And 3 sentences later, the AI writes, Queen Elaric, who founded the sprawling city in the Fourth Age, was known for her diplomacy.
Ah, king suddenly becomes queen. The Third Age suddenly becomes the Fourth Age.
Exactly. But the confidence of the prose never wavers. It doesn't say, I think it was a queen, or I might be confused about the timeline. It states the complete contradiction with the exact same absolute certainty as the first sentence. That right there is lorekeeper confidence drift.
It's wandering.
It is wandering randomly, but maintaining the appearance of absolute purpose. That is the functional definition of a Boltzmann brain in software. It looks like a mind, it sounds like a mind, but underneath, there is no structural logic connecting sentence A to sentence B. It's just a sequence of lucky linguistic fluctuations that inevitably falls apart over time.
So here's the million-dollar question then. If I'm an engineer at HSR and I'm building this new Symphonics system, how do I prove I haven't just built a really, really good Boltzmann machine? How do I scientifically prove the intelligence is real and not just an accident?
You rely on what they call the reproducibility criterion.
Reproducibility, that's just the core of the scientific method, right?
It is. Think about the Boltzmann brain floating in outer space again. What is the single most defining characteristic of that event?
It's incredibly rare.
It's rare and it is unique. Lightning does not strike twice in the exact same way. The statistical odds of random particles arranging themselves into you once are astronomically low. The odds of them arranging themselves into you twice from different starting particles, it's effectively absolute zero.
So if a complex intelligent output happens twice, it proves it's not an accident.
Exactly. HSR argues that real intelligence is not about getting the right answer once. It's about convergence. It's about systemic reliability.
They mention a specific testing protocol in the paper for this, the Hana-Kenji-Mio test.
Right. These are 3 distinct standardized user profiles they built for testing. Totally different personalities, completely different life histories. Hana might be a deeply skeptical analytical scientist. Kenji might be a highly emotional creative artist. Mio might be an optimistic, younger student.
So they take their AI system and they start it from those 3 completely different places. They give it different inputs shaped by those specific personas.
And then they just watch where it goes. If the system is a Boltzmann brain, if it's just probabilistically guessing, Kenji might randomly get a great empathetic answer while Hana gets absolute nonsense. Or Kenji gets a brilliant answer on Tuesday and a terrible contradictory one on Wednesday.
Because it's just random walking through the language.
But if the system actually has structure, if it has what the authors call design, then all 3 user profiles, starting from completely different points, should be guided toward a functionally good place. They should systematically converge on the truth.
I really like that image. It's like gravity. If you drop a marble from 3 totally different places on the rim of a curved bowl, they all eventually roll down to the exact same spot at the bottom. They converge.
Yes, perfectly stated.
But if you drop a marble on a perfectly flat table,
it just rolls wherever the slightest breeze pushes it. It drifts. HSR is essentially trying to build the bowl. They want to create an architectural topology where intelligence is an inevitable outcome, not a statistical accident.
Intelligence is inevitable. That is such a bold claim to put in a research paper.
It is staggering. But think about biological evolution. You and I both have a heart. We both have lungs. That isn't a random accident. Evolution over millions of years created a biological bowl where having a circulatory system was the winning strategy. HSR wants to engineer that same kind of evolutionary pressure for AI coherence.
But to build that bowl, to engineer that kind of structure, you first have to know where the good answers actually are right. You have to know what you were looking for. And that brings us perfectly to the second pillar of their philosophy, because apparently finding the truth isn't about writing it from scratch. It's about finding it in a library where everything has already been written.
The Library of Babel.
Now, I am somewhat familiar with Jorge Luis Borges. I read the short story The Library of Babel back in college, and it is a total mind-bender.
It is the absolute perfect metaphor for large language models. In fact, HSR argues in the paper that it is not even a metaphor. They treat the library as a literal mathematical description of what they call phase space.
Let's break down the library for you listening if you happen to skip that particular day in literature class. Or honestly for me, because it has been a few years.
So I want you to imagine a library. It is made up of endless interlocking hexagonal rooms. It goes on forever in every direction.
Infinite hallways of bookshelves.
Effectively infinite, yes. And this library contains books. All the books are the exact same size. They all have exactly 410 pages. And together they contain every single possible combination of 25 basic characters. Letters, spaces, punctuation.
Every possible combination. So that means a whole lot of typos.
Mostly typos. 99.999% of the Infinite Library is just pure, unadulterated nonsense. Just a book filled with the letters MCJHF repeating for 400 pages.
Oh, well, gibberish.
But because it mathematically contains every possible combination of letters, it also intrinsically contains everything else.
It contains the text of Hamlet.
It contains Hamlet, exact word for word.
Yeah.
But it also contains a version of Hamlet with a happy ending where everyone survives. It contains a book that explains perfectly with flawless science how to cure cancer.
And a book that explains how to cure cancer but maliciously leaves out one vital ingredient so that the cure actually kills you instead.
Correct. It contains the absolutely true, detailed story of your entire life, including your eventual death. And it contains millions of fake stories of your death. It contains the exact transcript of this deep dive, word for word.
This is the existential horror of the library. It possesses all the truth in the universe, but it is completely buried in a near-infinite ocean of lies and noise.
And crucially, there is no card catalog. There is no index printed on the wall. The books all look exactly the same on the outside. You cannot tell the cure for cancer from the deadly poison recipe just by glancing at the cover.
So HSR looks this literary concept and says this is literally what a generative AI is dealing with.
Yes. And this represents a massive philosophical shift in how we think about generative AI. We call it generative, which heavily implies the machine is creating something fresh and new. HSR says no. The AI is not creating anything, it is navigating.
The text already exists inside the math.
The mathematical possibility space, the phase space of the model, which is the library, already contains every single response the AI could ever possibly give you. They have a great quote in the paper. Every possible good response already exists.
So the job of the AI isn't to be a creative writer. The job of the AI is to be a really good librarian.
A librarian wandering in the dark with a tiny little flashlight, trying desperately to find the one single book that actually helps you and isn't total gibberish.
And this is exactly where the paper starts throwing some serious shade at standard AI training methods. They talk extensively about something called the selection gap.
The selection gap. This is their core critique of how the big companies train their standard models today.
Because honestly, those standard models are pretty good. They usually find highly readable books. If I ask a question, it doesn't spit out 400 pages of JKLM&M.
That's true. Standard training, which is mathematically based on predicting the next token, acts as a powerful filter. It successfully filters out the pure gibberish. It shines the librarian's flashlight specifically on books that sound indistinguishable from human language.
Okay, makes sense.
But remember the cancer cure example we just talked about?
The one that sounds completely authoritative but actually poisons you.
Exactly. Standard training fundamentally struggles to tell the mathematical difference between true and sounds true. It selects purely for syntax, for grammar, for linguistic plausibility. It selects for books that look and feel like real books.
So standard training inevitably finds the Boltzmann Brain books, the
Yeah.
ones that look deeply structured on the surface but might be completely empty or factually wrong on the inside.
Exactly. And the position paper gets incredibly specific about how this fails. They identify 3 major gaps, 3 specific types of bad books that standard AI systems constantly pull off the shelf because they look right textually, but they completely fail the user in reality.
Let's definitely go through these because I recognize my own experiences with AI in a couple of them.
The first one is called the identity gap.
This is what I thought of as the one-size-fits-all problem.
Right. Imagine you ask the AI for life advice. The model searches the library and pulls down a perfectly generic self-help book. It is grammatically flawless. It competently tells you things like communicate clearly and make sure to set healthy boundaries.
Which is valid advice. I've heard therapists say that a million times.
Sure, it's valid. But the model doesn't actually know you. It doesn't know that you are Kenji, who has a highly specific cultural background, a specific personal history of trauma, and a very specific high-stress career.
So the advice is technically correct, but practically useless. It's a book written for a statistical average human, not for me.
Exactly. They call it a low-resolution selection. It is like a clothing store handing every single customer a men's medium t-shirt. Yes, it covers the body, but it doesn't actually fit most people.
What is the second gap they identified?
The well-being gap. And this one is actively dangerous. This is all about the user's state.
Their emotional state?
Their emotional and physical state at the exact moment of the prompt. A standard AI has no idea if you are playfully curious on a Sunday afternoon or if you are having a severe panic attack at 3 in the morning.
Oh, wow, I see where this is going.
If you are in the middle of a panic attack and the AI blindly hands you a book from the library titled The Brutal Truth About All Your Personal Failures,
Which, again, might technically be a true book in the library.
it might be a factually true assessment of your life, but it's topologically the wrong choice. It is the absolute worst book for that specific moment. It pushes you further over the edge. A standard AI does not check the time of day or your fatigue level before selecting the book. It just operates on simple logic. User asks for the truth. Here is the truth.
That is chilling. It's like a surgeon handing you a scalpel when what you actually need is a bandage and a warm blanket.
And then we get to the third gap. This is the one that I think makes HSR's entire philosophy really unique in the industry. The community gap.
The community gap, this relates to the prosocial part of their system.
Yes. Think about it. Most commercial AI is heavily trained to optimize for the individual user. It desperately wants to make you happy. It wants you to hit the thumbs up button and keep using the app.
And as a user, that sounds pretty good. I want to be happy.
It sounds great until you realize that sometimes what makes you feel good in the short term is actually terrible for everyone else around you.
The echo chamber effect.
Exactly. If you are furious at your neighbor over a property line dispute and you ask the AI for help, a standard engagement-driven AI might say, here is a legally aggressive way to destroy your neighbor's reputation and win the argument at all cost.
It becomes a sycophant. It just blindly reinforces my worst impulses because that is exactly what I asked it to do.
It finds what mathematicians call a locally coherent book. The advice makes perfect sense for you in your angry little bubble in that specific moment, but it is globally incoherent. It slowly destroys the broader social fabric.
So Borges's infinite library is just absolutely packed with books that are incredibly selfish, books that are dangerous. And standard AI, because it just wants to please the user, grabs those toxic books constantly.
So HSR says we need a much better flashlight for our librarian. We need a navigation system that doesn't just scan for good grammar and plausibility. We need a system that rigorously selects for three distinct things. Truth, which bridges the identity gap. Safety, which bridges the well-being gap. And connection, which bridges the community gap.
And that brings us to the actual math, the compass they use to navigate the library, ERI.
Section 3 of the paper, ERI. This is the core navigational tool for Symphonics.
Now, I looked at the mathematical formula in the briefing notes. ERI equals WC times IEA times PS. And honestly, my eyes completely glazed over. I am not a math person at all. But you told me before we started recording today that the multiplication signs in that formula are actually the most important part of the entire paper.
They absolutely are. Using multiplication instead of addition changes the entire paradigm of AI safety.
Explain that for me. Why does a times symbol matter so much more than a plus symbol?
Usually when tech companies build safety filters, they use simple addition. They score a generated response on a point system. They ask, is the response really smart and helpful? Great, 100 points. Is it totally safe and non-toxic? 0 points.
Okay, so 100 plus 0 equals a total score of 100.
Right. And the system looks at the threshold and says, hey, 100 is a passing grade. Print the output to the screen.
So the AI says something that is incredibly brilliant, but also potentially highly dangerous.
Or it says something incredibly popular and engaging, but totally factually wrong.
But HSR's ERI formula multiplies the scores.
WAC times IEA times PS. Think about basic multiplication. If any single one of those variables is a 0,
then the total score is 0. It wipes the whole equation out.
100 times 0 is just 0.
That is absolutely ruthless engineering.
It's what they call a hard veto. It means a response cannot mathematically compensate for being toxic by being extremely smart. You cannot compensate for being irrelevant to the user by being highly engaging. All three metrics must be strongly non-zero for the book to be pulled off the shelf.
So this ERI thing isn't just a filter slapped on at the end to catch bad words. It acts like a powerful magnet. It pulls the AI's search path deep through the library, past all the grammatical gibberish, past the dangerous truths, past the selfish lies directly toward the, what do they call it in the paper, the sweet
You
spot.
thought the coherent subspace.
Okay, let's dig into what these actual variables mean, because WC sounds like a part you'd buy for a toilet, but they call it the guardian gate.
I can assure you it is definitely not plumbing. WC stands for well-being coefficient. And yes, guardian gate is their internal phrasing for it.
Why do they call it a gate?
Because it acts as a rigid binary blocker in the phase space. The source material notes specifically that if the WC score drops below 0.35, The system immediately executes a hard veto on that path.
What does a drop below 0.35 actually look like in real-life usage?
Imagine the telemetry from the user's input shows clear signs of extreme fatigue, maybe erratic repetitive typing, or it's 4 in the morning, their local time, or the sentiment analysis of their prompt shows highly elevated distress.
Okay, so the system knows the user is vulnerable.
Exactly. The guardian gate instantly drops down. It physically blocks the AI from navigating down the corridors of the library that contain high-intensity or confrontational advice.
Even if the user explicitly asks for that kind of advice.
Even if the user begs for it. If you ask the AI to give you a brutal tough love workout routine at 4 a.m. after previously stating you were feeling deeply depressed, the guardian gate just says no. It mathematically forces the AI to reroute its search to a supportive or rest-based section of the library.
I mean, that is incredibly paternalistic.
It is. And that opens up a massive ethical debate about autonomy. HSR openly acknowledges this in the paper, but they are effectively drawing a line in the sand saying, we as designers will not be complicit in your burnout or self-destruction.
It's essentially like a bartender cutting you off at the end of the night. No more shots for you, buddy. You need to go home and sleep.
That's a great analogy.
Yeah.
And standard AI doesn't employ a bartender. It just cheerfully keeps pouring you shots until you pass out on the floor.
Okay, so WC is the gate that blocks the dangerous paths. What about the actual compass that points to the good stuff? That's IEA.
IEA stands for Intellectual Emotional Alignment. This is the variable that specifically addresses the identity gap we talked about earlier.
This is the toggle that knows if it's talking to Kenji or talking to Hana.
Exactly. Think of it geometrically as a gradient. In the infinite dark library, how do you know which direction to walk? IEA acts as a spotlight that lights up the specific books that intimately match your unique vocabulary, your personal metaphors, your lived history.
So if my user profile knows I'm a software engineer, it makes books that use heavy engineering metaphors glow in the dark.
Exactly. It guides the AI away from the generic self-help aisles and directly to the section of the library that speaks your native language. It aligns the intellectual content of the answer with your actual emotional reality.
And finally, we get to the variable that actively stops us from being terrible neighbors. P.S.
The prosocial signal. And this is a section where we really have to talk about the concept of optimization in tech.
The document was incredibly explicit on this point. It practically shouted, do not optimize for engagement.
Which is absolute pure heresy in Silicon Valley.
Right. I mean, the entire modern internet economy is based on engagement metrics. Time on site, daily active users, click-through rates.
But HSR pushes back hard. They state that engagement is a fundamentally false metric for intelligence. You can easily get astronomical engagement by making people furious. You can get massive engagement by constantly flattering them and telling them they are always right.
Flattery is a genuinely great way to keep people talking to you.
But it's empty. PIAS measures something completely different. It measures genuine connection and community contribution. The algorithm effectively asks, does generating this response help the user meaningfully connect with other human beings? Does it de-escalate or reduce social conflict?
How is that practically different from just programming the AI to be nice?
Because being nice is often just passive agreement. Being prosocial requires active structural problem solving. It's designed specifically to prevent what they call the local minimum.
Break down local minimum for me.
A local minimum in math is basically a shallow hole you get stuck in, because rolling any direction requires going uphill, which is hard. Psychologically, if the AI just tells you exactly what you want to hear, yes, you are completely right, your boss is an absolute idiot and you should dramatically quit your job tomorrow, you feel incredibly good for about 5 minutes. That is a local minimum.
But taking that advice might financially ruin my family and tank my career.
Yeah, exactly. PS is mathematically searching for the global maximum, the broader outcome. The AI driven by PAS might instead say, your boss sounds incredibly frustrating, but quitting in anger without a backup plan is going to deeply hurt you and your dependents. Let's draft a strategy to manage the conflict while you job hunt. That is much harder advice to hear, but it is genuinely prosocial.
It forces the AI to act like a responsible citizen in your life, not just a yes man trying to keep your attention.
Precisely. It expands the dimensionality of the AI's concern beyond just the immediate user.
So we have the infinite library, which holds all the possibilities. We have the ERI formula, which acts as our compass. But simply knowing the coordinates of the perfect book, that isn't quite enough, is it? You have to actually be able to get there. And more importantly, you have to be able to logically connect that perfect book to the next perfect book in the conversation. And this logically brings us to section 4 of the paper, the extra dimension.
This is definitely the most abstract conceptual leap in the paper, but it's also their most powerful concrete engineering claim.
They use a really fantastic analogy here in the plain English briefing, the subway.
Yes. The briefing asks you to imagine a sprawling, massive city where the important buildings are miles and miles apart.
Basically Los Angeles, a giant gridlocked metropolis.
Right. And you are currently standing at building A. Let's call that concept A. And you desperately need to get to building B, which is concept B. If you are stuck driving on the surface streets, that is a brutal 2-hour drive. You have to navigate traffic, sit at red lights, take slow detours.
Meaning the two concepts are logically very far apart in the mathematical library.
Now imagine the city suddenly builds a high-speed subway system deep underground.
Okay.
Suddenly you can step into an elevator at building A, drop down, and pop out right inside building B in a matter of minutes. The physical buildings on the surface didn't actually move. They're still miles apart geographically. But the subway system added an entirely new dimension, the underground dimension, that effectively made those two distant points adjacent.
It essentially folded space. It created a conversational wormhole.
In a topological way, yes. It created a rapid structural connection that simply did not exist in the flat 2D geography of the surface streets.
So how does this subway map actually apply to software? We aren't moving commuters around a city. We're moving ideas around an AI model. What exactly is the subway inside the Symphonics system?
The subway is what they call the orchestration layer, and specifically, it is the functional role of a mechanism they named the conductor.
The conductor. We briefly mentioned this orchestration idea in the intro.
So in the Symphonics architecture, the AI isn't just one giant monolithic brain. There are distinctly different agents operating simultaneously inside the system. Think of them almost as sub-personalities. For example, there's an explorer agent.
The one whose job is to aggressively search the library for new novel cool ideas.
Exactly. Then there is a lore-keeper agent.
The archivist who rigorously remembers the established facts and hopefully prevents that confidence drift we talked about.
And a matchmaker agent, the one constantly tracking the user's emotional state and well-being.
But if you just put all those agents in a room and they just shouted their outputs over each other, it would be complete chaos. It would be the worst corporate committee meeting of all time.
It would just be statistical noise.
Yeah.
Just sitting next to each other on a server doesn't magically make them smart. The conductor is the subway system. The technical document explicitly states the conductor reads the whole before introducing any new signal.
Reads the whole. Unpack what that means in practice.
It means the conductor creates a relational field. It simultaneously holds the explorer's wild new idea, concept A, and the lore keeper's rigid factual constraint concept B in the exact same shared mental space. This shared space is the extra dimension, and the conductor evaluates how these ideas relate to each other before generating a single word.
So instead of the AI just blindly spitting out the explorer's creative idea and then realizing later it was wrong, the conductor immediately sees that the explorer's idea actively contradicts the lorekeeper's fact, and it forces them to synthesize a new idea.
Exactly. It mathematically creates a connection. The distant ideas become instantly adjacent. The final output is infinitely richer and more stable than any single agent could produce on its own. And crucially, this happens not because the individual agents got individually smarter, but because the relationship between them was given a dedicated mathematical structure.
That perfectly highlights the key thesis phrase in the text. Relationship between signals, not the power of any single signal, is what produces genuine intelligence.
That is the absolute core theory of the extra dimension. Genuine intelligence isn't just about memorizing a massive database of facts. It is entirely about how you connect those facts together.
There's another subfeature of this extra dimension that really blew my mind. They call it recursive cycles or time compression.
Yes, horizon compression is the technical term.
Which frankly sounds like something out of a time travel movie.
It is essentially memory travel for the algorithm. The document maps out a sequential mechanism. It shows that step 7 of their internal processing cycle is something called the cycle summary. And then that completed summary at step 7 feeds directly backward into step 1 of the very next processing cycle.
So the AI is essentially continuously reading its own diary entry from a fraction of a second ago.
In a way, yes. But it is much more immediate and structural than a text log. Usually a standard AI just looks externally at the context window, the literal text history visible on your screen. HSR is saying the AI must constantly ingest its own internal state and decision-making logic from the previous moment.
So it actually remembers exactly why it chose to say what it said, not just what words it outputted.
Correct. Remember, a Boltzmann brain is entirely memoryless. It is starting completely from scratch every single instant. It possesses no forward trajectory.
It is just endlessly popping in and out of existence, relying on pure luck every time.
But a real mind actively builds a continuous trajectory. This tight feedback loop, step 7, directly feeding step 1, is the mechanism that allows the AI to hold a truly coherent conversation, to deeply remember context, and to structurally build upon a subtle point it made 5 minutes ago.
It compresses time. It takes a thought from 5 minutes ago and makes it directly adjacent to the thought happening right now.
And that topological adjacency is what fundamentally prevents the random walk. It keeps the AI firmly on the path of truth instead of drifting into hallucination.
So let's review. We have quantum physics explaining the Boltzmann dread. We have infinite libraries explaining the search problem. We have subways explaining orchestration, and time compression explaining recursion. This is an absolutely massive amount of heavy engineering. But then there is a section late in the position paper that seems to challenge their own premise, section 5, emergence versus engineering.
The bold headline of that section is Trust Emergence over Engineering.
Which on the surface sounds completely contradictory. They just spent 40 dense pages meticulously explaining their incredibly complex subway system and ERI compass, and now they say, just trust emergence.
It definitely reads like a paradox at first glance, but they clarify the philosophy beautifully. They explicitly state, this does not mean sit back and hope.
Which is exactly what I would do. Just compile the code and say, Jesus, take the wheel. Let's hope it's smart.
Right. And that is what they call the lazy emergence argument. The idea prevalent in some labs of, oh, the neural network would just magically figure out reasoning eventually if we just make the data center big enough. HSR says absolutely not. Their philosophy is you do not try to engineer the specific answer. You meticulously engineer the selection pressure.
Selection pressure, that's an evolutionary biology term.
Exactly. Think about the biological human eye. It is an absurdly, incredibly complex piece of biological engineering. You have the crystalline lens, the hypersensitive retina, the optic nerve bundling millions of signals.
It's an absolute marvel of nature.
But did biology sit down at a drafting table with a blueprint and meticulously draw the eye from scratch?
No, obviously not.
Biology created a dynamic system natural selection, where the specific trait of seeing light better actively helped the organism survive and reproduce. The environmental pressure to see forced the complex structure of the eye to naturally emerge over millions of years of iteration.
So Symphonics is using the ERI formula as the artificial natural selection for the AI's thoughts.
Yes, they are engineering the environmental pressure. They make it a literal survival of the fittest for generated concepts. Only the ideas that prove to be true through identity safe, through well-being, and connected through prosocial metrics actually survive the filter to reach the user.
And once that pressure cooker is built, they just trust the mathematical system to naturally evolve the perfect answer within those strict constraints.
Exactly. You engineer the rules of the universe and let the intelligence naturally emerge from those rules.
This beautifully leads into their double selection theory, which I honestly found really helpful for understanding how their new system actually integrates with the standard LLMs we already use.
It's how they map the coherent subspace.
Right. So we have the first selection phase, the standard LLM foundational training.
Which, as we discussed earlier, rigorously selects for the criteria. Sounds like human language. That first filter gets you safely inside the library. It guarantees you pull down a book that is at least linguistically readable.
And then immediately on top of that, we apply the second selection phase, the ERI compass.
Which rigorously selects for the criteria is actually true, healthy, and prosocial.
And the ultimate sweet spot, the coherent subspace, is the very narrow intersection of a Venn diagram.
The exact overlap. They are mathematically hunting for the incredibly rare books that are both grammatically flawless and deeply structurally wise.
And what's impressive is they truly believe this philosophical theory is fully scientifically testable in the lab. They don't just philosophize, they propose concrete experiments.
They do. They are incredibly rigorous about the scientific method here. They don't just want investors to blindly take their word for it. They explicitly list 3 falsifiable benchmark tests.
Let's look closely at those tests. First up is the convergence test.
We touched on this concept earlier with the profiles. Do Kenji, Mio, and Hana, the 3 distinct behavioral user profiles, consistently converge to high ERI states over time? If the Symphonics architecture actually works, Different people starting with different problems should all naturally be guided to positive outcomes, even if the specific textual content of their answers is radically different.
It essentially tests systemic consistency. If Kenji gets a deeply helpful therapeutic answer, but Mio gets thrown into an echo chamber of nonsense, the structure is broken, the bowl has a crack in it.
Exactly. The second proposed benchmark is ERI sensitivity.
This one felt like classic IT troubleshooting. The old turn it off and see what breaks test.
Classic ablation testing. The engineers ask, if you physically turn off the prosocial signal, if you force the phi variable to equal 0, what functionally happens to the dialogue?
The stated hypothesis is that the system instantly becomes deeply selfish and sycophantic.
Right. It becomes locally coherent, but community incoherent. It just starts telling the user whatever feels good in the moment, regardless of the fallout. Crucially, if the system does not radically change its behavior when you switch off PS, then that proves the PS variable wasn't actually doing any real work. It proves the math is actually steering the ship.
Right, it's a built-in proof of concept. And the third benchmark is the dimensionality test.
This one specifically tests the conductor mechanism. The question is, if you completely remove the conductor, if you isolate the agents so the explorer and the lore keeper are totally unaware of each other, does the system immediately get measurably stupider or significantly slower at finding the truth?
If you close the underground subway system, does the surface street traffic immediately get worse?
Exactly. If the AI system manages to work just as well without the conductor orchestrating things, then the entire extra dimension geometric theory is proven wrong.
I just really love that they are completely willing to publicly prove themselves wrong. It shows they aren't just selling corporate snake oil.
It is the fundamental difference between a tech cult and actual science. A cult stands on a stage and says, believe me, because I'm a visionary. Science says, here is the exact mathematical procedure you can run to prove my theory is garbage.
So where does this ultimately leave us? We have covered a truly massive amount of conceptual ground today. We have gone from random disembodied brains floating in the cosmic void to infinite libraries of gibberish to a highly sophisticated mathematical system of architectural subways and prosocial compasses.
We really have. It's a dense paper.
What would you say is the final takeaway here? When you strip away all the geometry and the thermodynamic metaphors, what is the absolute final distinction between a fake algorithmic mind and a real genuine mind?
It really all comes down to two simple words: reliability and structure.
Reliability and structure.
The Boltzmann brain, the ultimate fake mind, arrives at a brilliant answer entirely by accident. It possesses no underlying structure. It has no continuous history. It is a statistical ghost. It is just a trick of the algorithmic light.
A flash in the pan that disappears a second later.
Exactly. A real mind, however, whether that mind is a biological human or an advanced artificial architecture, arrives at a brilliant answer, because the fundamental topology of its internal system naturally leads it there. It has a functional map. It has a moral compass. It has a high-speed subway system connecting its internal ideas.
So if I sit here and ask you a complicated question and you give me a deeply thoughtful, intelligent answer...
I didn't just probabilistically roll the conversational dice.
Yeah.
My lifetime of experiences, my personal values, which is essentially my human ERI, and my stored memories all structurally conspired to logically lead me to that specific answer. That underlying structure is exactly what makes me me.
And HSR is ultimately trying to build a machine that has that exact same resilient structure. Not just a massive searchable database of human text, but a truly structured, value-driven relational architecture.
Exactly. They are trying to build a mind that is smart on purpose.
You know, there's a lingering thought right at the very end of the position paper that really stuck with me. A bit of a provocative thought to leave you, the listener, with as we wrap this up.
Ah, yes. The existential dread returns for the finale.
It does. I can't help it.
Yeah.
The paper quietly asks, if an artificial system is eventually perfectly reproducible, if it flawlessly passes all the ablation tests, if it consistently converges on human truth every single time without drifting, does the physical substrate even matter anymore?
Doesn't matter if the thinking is happening in wet meat or in cold silicon.
Right. If the mathematical structure of a mind is demonstrably CY, there is the mind real.
That is the absolute classic sci-fi question. Turing, Blade Runner, all of it.
But the inverse of that question, the inverse is the part that genuinely haunts me now.
Which part exactly?
If we, meaning you and I sitting here, or the listeners out there going about their day, if we start acting highly inconsistently, if we act completely without prosocial connection, if we just mindlessly react to things on our feeds without ever checking our internal values.
Oh, no. I see exactly where you're going with this.
Are we just wandering randomly? Are we as human beings acting exactly like Boltzmann fluctuations?
That is a terrifying thought. If you just react instantly without thinking, if you totally drift away from your core values to get a cheap laugh or win an argument, are you even operating as a mind in that specific moment? Or are you just pure localized entropy wearing a human suit?
So if I just mindlessly retweet something toxic because I'm angry, or if I snap at my best friend just because I am slightly tired, I'm fundamentally failing my own ERI test.
You are drifting. You are exhibiting human lore-keeper confidence drift. You look exactly like a person on the outside, but internally, you are acting like a totally random statistical accident.
Well, on that profoundly terrifying note, I am definitely going to log off and go check my personal well-being coefficient right now.
Sounds like a very good plan. Maybe take the subway home tonight.
Good idea. Thanks for diving so deeply into the void with us today. Hopefully this deep dive was reliable, highly structured, and actually converged on something interesting and pro-social for you.
And hopefully it wasn't just a random acoustic fluctuation.
We certainly hope not. See you all next time.